Hello and welcome back to the Linux Panic YouTube channel. This is video 1 in my second Linux from Scratch series. In this series we're going to be going over stable LFS version 11.2. So let's get into some of the details before we move onwards. Linux from Scratch is a toolbook that will allow you to build your own Linux distribution from scratch, it's kind of in the name. So let's get on with it. So, as we can see here, I'm currently in the book at linuxfromscratch.org/lfs/view/stable chapter and so on. There are a few things that we need to do. Firstly, we need to come to the book, and because I'm using Ubuntu version 20.04, there are a list of things that we need to install. I'll just make them appear once we have changed our shell emulator around. So to do that, we need to do sudo -i to go into root, and it's dpkg -reconfigure dash, and we will leave this set to no. Hit enter. We need to go into software and updates and check to see if the universe and multiverse repositories are enabled. In this case they are, so we can just close that. And because we're using Ubuntu 20.04, we need to download some software. So we need to download and install the following software. We need to download and install M4, Gork, Bison, Flex, Automake, AutoConf, Build Essential, TextInfo, Gparted, libncurses 5-deb, libncurses w5-deb, and libtool. As I have already installed all of those, we can just move on to the next step. And that is to check our compatibility with the host system requirements. In chapter 2.2 of the book, it says your host system should have the following with the minimum versions indicated. This should not be an issue for most modern Linux distributions. So what we'll do is we will copy everything that is here, hit enter on the thing that pops up, and have a comparison between the two. So bearing in mind this number indicated here is the minimum version that is needed. So let's start at the top. Bash exceeds the minimum version. Bin bash should be a symbolic hard link to bash, which it is, as we can see here. Bin utils 2.34, it is greater than that. Versions greater than 2.39 is not recommended. This is 2.34, which is good. Bison 2.37, that exceeds the minimum. User bin yak should link to Bison or a small script that executes Bison. As we can see here, user bin bison.yak, good. Core utils exceeds, which is good. Diff utils exceeds. Find utils exceeds. Gork user bin orc should link to Gork. As we can see here, GNU orc links through, which it does. User bin Gork instead of user bin orc. We now have GCC. In this case, it exceeds, including the C++ compiler G++. Versions greater than 12.2.0 are not recommended as they have not been tested. C and C++ standard libraries with headers must also be present so the C++ compiler can build hosted programs. In this case, as we can see, GCC is no greater than 12.2, but it's higher than 4.8. And as we can see here, G++ is the same, so we're good to move on to grep, which exceeds. gzip, as we can see here, is above because it's version 1.10 instead of version 1.3.2. Linux kernel version exceeds because this is using the 5.13 kernel, which is good. The reason for this kernel requirement is that we specify with the version when building glibc in chapters 5 and 8. At the recommendation of developers, it is also required by udev. If the host kernel is earlier than 3.2, we'll need to replace the kernel with a more up-to-date version, which we don't need to worry about because we're using an up-to-date version. As we can see here, M4 is greater than 1.4.10, it's 1.4.18. Make is 4.2.1, which is greater than. Patch is 2.5.4, we have 2.7.6, which is greater than. Perl is 5.8.8, and the version we have is 5.30.0. Python is 3.8.10, which exceeds. Sed is 4.7, which exceeds. tar is 1.30, which exceeds. TextInfo, as we've just installed it, is 6.7, which exceeds. XZ Utilities is 5.24.4, which exceeds. And we're now okay, everything ran fine. So we've just confirmed everything is good. As we can see here, this is just a breakdown of how things are working and how things will work. That's there for you to read later on, because there are some chapters that, or there are some packages that will take quite a while, so it is worth having a read. So this is where we need gparted to begin with. We have a 50 gigabyte disk size. I'm using 50 gigabytes because that's what I've assigned. So the first thing we need to do is we need to give our disk here a partition table. In this case, it will be an MS-DOS partition table, because this is less than 2 terabytes in size. And we need to apply 3 partitions to it. The first one being the boot partition under ext2. So the new size will be 512 megabytes in ext2. We'll call this boot. The next partition will be 40.5 kilobytes. And we need to have a free space following of 4096. This, what we've just made here, will just be the rootfs, so we'll just go rootfs. And then the final space here of these 4 gigabytes left will be swap. We'll give that Linux swap and just call it swap. Click add, click the little green tick. I'm sure I wish to apply the changes. And now we need to come to the boot partition, manage the flags, and then give it the boot flag. Click close. We don't need to change it again because it's got the boot, so it's fine. And now if we list our block sizes, we have virtual disk 1, 2, and 3. For me, because I'm using a Virt Manager virtual machine, it comes up as VDA. For you, it should come up as SDA 1, 2, and 3. Now that we've done that, we could have done that in the terminal, but we can also do that in LFS as well, so that's fine. Not LFS, in gparted as well, so that's fine. So what we need to do now is we need to export the LFS variable. So what that means is anytime we type $LFS, it'll go to /mnt/LFS first before anything else. So it is important we do pay attention to that. So what we need to do now is we need to do export LFS equals mount LFS. So just do that, and then echo LFS. As we can see here, this has worked, which is good. Always, one way to ensure that LFS is variable we will always set is to edit the .bash profile in the home directory, or in the home directory and the root directory. But because we don't have a home directory, this is fine. So what we need to do now is we need to make the directory LFS, because if we try and cd into LFS now, it's just going to say there's nothing there. What we need to do is we need to do make directory -pv $LFS. So we now have the directory there, and we need to mount our rootfs directory. So to do that, we do mount -v-t. ext4 is the partition table. dev/vda2 in my case. So as you can see, cannot find in the fs tab, which is fine. What we need to do is fix that. Now, the reason how we can fix that is because we haven't added anything on here. So to do that, we just do LFS. and now it's mounted it. And it's just as simple as just a simple mistake like that can throw you off rather easily. But because we saw what it was and fixed it, everything's fine again. We'll just do one more list blocks, as we can see here. Our root is now LFS, which is good. We clear that off. We now want to make a directory in the another one, and this time it's LFS/home. And if you're using multiple LFS partitions, e.g. one for slash and one for home, then I'm using that. But because we're not, everything's fine. So it is also worth paying attention to what you're typing. So we're just going to do remove directory rm-r/mt/lfs/home and do ls-la. As we can see here, that is set up correctly. I'm going to do cd lfs. We have what we want. So this is good. So we've mounted that, and that's all sorted out. And what we want to do now is we want to enable the swap space we made earlier on. So we do /sbin/swap on -v/dev/vda3. As we can see here, the swap size was created with no bother at all. We move on to the next part, where it just says what we need to make is a sources directory. So we can do that with make directory -v $lfs/sources. Made that. And we need to enable this to be sticky, which means anybody can write to it, but only the owner of the directory can remove from it. So as simple as just doing that. So it goes from a 0755 to a 1777 or RWX, RWX, RWT instead of RWXR-XR-X. So it's always something worth remembering. And now we need to get two files. Now it doesn't give you the links to the files, but it is worth paying attention. So the first thing we need to do is we need to get the wget list file, and to do that we just do wget. We need to make sure we're in the sources directory. First we're going to do cd sources wget that, and if we do cat wget, all the links are in here for what we need, which is good. So clear that, and now we run this command, and this will get everything that's on the list and download it, which is good. Now, through trial and error and totally not having butchered 3 attempts of this already, I know there are two files missing, so we will need to get them later on once we've figured out what they are. So whilst that runs, we just need to grab the MD5 sums file. So this will just check against all of the sources to make sure what's there and figure out what we need to download again. We'll just figure out what we need to download. It just compares it to known MD5 sums. We can then work backwards. Wait for this to finish off. Shouldn't take too long. As we can see, we're now currently done. I'm about to say we're now currently done. We're coming towards the end as we're just waiting for Vim to finish download. There's XZ. And as we finished, it took a total of 59 seconds to download nearly half a gig, which is fine. So we need to wget not 59. We need to get the MD5 sums. We grabbed that, and now we need to run the MD5 sum file. As we can see here, there are two that failed the list. It's zlib 1.2.12, and it is also expat 2.4.8.tar.xz. So what we can do is we just do copy and do this, and it'll appear we have to grab this from expat. What we're looking for here is expat 2.4.8. 2.4.8, grab that, and then come to the releases and look for 2.4.8 and look for the .tar.xz, which we have here. We also need to grab zlib 1.12.2 from Mac ports because it is not available from the creators website. So we just copy that in, go to Mac ports, zlib, and we're looking for 1.2.12 as we can see here. 1.2.12. I want to save that. As we can see here, both of our files are done. So what we want to do is we want to cd into downloads, even cd downloads. This is where I jumped the gun a bit, so we want to do that. CD downloads, ls-la, mv expat, and zlib2 $, and before we actually do the $, go $lfs, export lfs equals /mt/lfs. We want to do mv expat and zlib2 $lfs/sources. And we want to do sudo -i, and want to again echo the LFS. And so it's export LFS equals /mnt/lfs. We have to do this because we haven't set the environment flags, so that's our fault, but it is what it is. Want to do clear and then do cd LFS sources. And now if we run the MD5 sum file once again, as we can see here, everything came back with no issues, so this is good. We can now move on to the next part. This just lists where we can download all the packages individually, so it is what it is. The patches also came down, as we can see, consolidate, well, .patch, that's fine. They came down, so we don't need to bother around with that. And we need to just finish off by creating some directories. Create the required directory layout by running the following as root. We've been doing that for a little while, but we're currently in the root directory. Go down to MNT. So we want to make these directories, as we can see here, LFS, as we can see here, it created a small problem. So if we do ls-la, it went LFS pushed D. For some reason unbeknownst to me. So what we need to do is we need to go -r LFS push D. I don't know why it created it like that. Echo. That's why the variable didn't work. So we want to do export LFS equals /mnt/LFS echo LFS. Now, if we print that, we get LFS instead of LFS push D. So this is why it's important to make sure you're doing everything correctly. But as we can see here, the directories we needed were etc var user bin lib sbin, etc var user bin lib sbin. Problem solved. This part here creates some links, and then this part here just changes the if it's a 64-bit system, it changes lib64 directory into just lib. As we can see here, it's created that, and we'll change that later on. So we'll grab this last one. This creates the tools directory that we will need later on. As we can see here, that was created. And we now need to create the user. So all it is just add the group LFS, add the user with all of these switches, which is just make bash the default user shell, add the user to the LFS group, creates a home directory for LFS, prevents copying of skeleton directories, and actually names the user LFS. So again, make sure you copy the right part, Add that in. And we give a password to the LFS user. So it's passwd LFS. In my case, I'll do that. It says by password. I don't know why Ubuntu does that, but it does. And what we now need to do is we need to grant the LFS user full ownership of everything that exists currently. Under LFS, we're just going to echo LFS, make sure everything's correct. As we can see here, ownership changed of everything, ownership retained as correct. Ownership of MNT LFS bin retained as LFS. So all of this is being done, set up a bother. And grab this last part, this changes that. Hit enter. And now we can log into the LFS user. And to do that, it's just su-LFS. We now have the LFS user, which is LFS at Ubuntu, which means it is working. So we need to set up the environment for our bash. This is the point where we could add the export LFS to export $LFS equals LFS MNT, and then we shall do, just to make our lives a little bit easier. The first thing we need to do is, whilst logged in as the LFS user, is set up a bash profile, hit enter, and now we create a bash RC file. Again, enter. And we are going to go into our bash RC file, so we're going to do vim.bashrc, nano.bashrc. Scroll right down to the bottom, and we're going to add two flags. First off is going to be export $make flags equals minus J4. Now, this will be used for later on when it comes to making packages. So we'll come across that later on. And we'll do export $LFS equals to /MNT/LFS. So whenever we do export $LFS in the LFS user, that's what we'll get. Save that. And now we need to just change this around. So we need to return back to the root user. So this is just preventing any conflicting of any bash RC files between users on the system. Run that and su-LFS. Now back to the LFS user. As we can see here, is not a valid identifier. Mount LFS is not a valid identifier. So this is why it's worth doing this now. So vim or nano.bashrc. As we can see here, this had a moment with me, so we're just going to do that and that. Log out, log in. As we can see here, equals minus J4 is not. So if we do echo LFS, that is set up correctly. If we do export LFS equals /MNT/LFS, and we do cd LFS, this is working correctly. So we'll just remove that from the bash RC file now. So, but what we haven't done is we haven't actually sourced the profile we created. So, we want to do cd, and then we want to do nano.bashrc. Now, the reason why it was chucking the errors is because we haven't sourced it to come up and actually apply these changes. So we need to do that now. As we can see here, make flags and all this is set. So, except these markers. And now we want to source this. So it's just simple as copy this, paste this in. Source that is not a valid identifier, but because it's having issues with it, we'll remove it just to placate it. Yes, and then we will source the bash profile. No issues anymore, and we can move on to the next step. See, this is explaining what a standard build unit is. The first package we make is measured in one standard build unit. That's how long things should take, but that's for in the future. And now we come to the end of video 1 of stable LFS. I hope you liked the video. If you liked the video, hit the like button. If you disliked it, hit the dislike. And whilst down there, maybe give the subscribe button a little tickle. Anyway, I have been Nick. You have been amazing. I hope you have a good rest of your day. Goodbye.